Yeah, recording.
Okay, so after the awesome lecture from Giuseppe and Oscar, I'm gonna try to.
What's your step? I didn't do anything.
Okay, awesome, Giuseppe. I'm gonna give you some little tips on how to actually make phone apps. For that, we're gonna use MIT App Inventor. That is a web interface that will allow you to create phone apps. Unluckily, talking about phones, as most of you know, there are several ecosystems. There is Windows Phone that almost nobody uses, doesn't have a great share of the market. And you have Android that takes most of the market, and iPhone. And that call is not iPhone, it's iOS. Talking about iOS and Android. As you know, iOS and all the Apple hardware software is a really close ecosystem. And by so, Apple has constrained a lot how to publish apps and how to develop apps for that ecosystem. And you want to enable like USB connections or even Bluetooth. Bluetooth of iOS has a quite particular protocol of connection, so it's not that straightforward to connect to with Bluetooth. And for example, RFID is embedded in all the iPhones, but they use a proprietary protocol and that doesn't allow you to use the RFID protocols as so. By so, I want to say that MIT App Inventor right now only works with Android. Why? Because with Android, we can install apps as a package, as let's say executable or DMG in case of OS X. That is a file that you open up and self-installs into your device. Why we can do it with Android? First, the kernel of Android is basically Linux, and the core is open, and they have left all the possibilities of using all the hardware of your phone open. That means it makes much easier to compile and everything. So let's say you want to write an app, you're an app developer and you write an app that everybody can download from the Apple Store or the Play Store. First, you have a big constraint. To publish an app in those stores, you need to be logged as developer. In Android, be logged as developer, it means paying some fees. The fees for Android are 25 euros, like forever. And in case of iOS, I think they are 99 euros or $99 a year. So that's why the big volume of apps in the Play Store are much larger than actually the Google Apple Store. What that Apple concern is actually to keep away bad developers or bad phone apps from being published into their ecosystem. So everything looks good and actually has a big constraint to actually who publishes app in their store. To publish an app for Android, you don't need to mandatorily go to the Play Store. You can download it as a normal file and just install as an installer package. Android has enabled some security features in the latest versions. So actually you need to hack, like override and take away some security features that are by default activated in your Android, but you will be able to install and make your phones in an easy way, and your apps in an easy way in any Android device. App Inventor was developed, of course, as the name says, actually it's not developed by the MIT, but is supported and maintained by the MIT, and they are keep enable new features. And actually right now is the MIT App Inventor 2. And they are making an ecosystem to actually publish in iOS, but it's in beta mode and it's not fully tested now. Actually, so you can produce apps, but you cannot compile them as a build package. So what we're gonna do is use the best points of phones, that is the wireless connections. So with this, I'm going to show you one example of using Wi-Fi connection to your phone and Bluetooth connection with your phone. Bluetooth, you don't need to mandatorily have a ESP. ISP32 has Bluetooth and Wi-Fi, and the ESP8266, that is a smaller brother of the ESP32, has only Wi-Fi. In case you have an Arduino, what you can do is actually use a Bluetooth module of Arduino. In this case, the most common one is to find this little guy that is called in general HC05 or HC06. There is different versions between both. One can only be master, one cannot be enslaved. You will see this into networking. What are the different? Both will work still the same. You can also find HC11. That is a Bluetooth 3.0 and 4.0, and I think it's also 4.0 Bluetooth protocol. That is a low energy protocol, but you can make it work as standard Bluetooth protocols. We will go deeper into Bluetooth and Wi-Fi, what is better for which application, into networking. So right now, let's just think as a tool that we can use in a more or less simple way. MIT App Inventor works as code blocks or Scratch. Actually, it's not this Scratch, sorry, Scratch code. So that means you work in a visual interface by making grabbing little pieces of code that are already written and just assembling like puzzles. By so that means it's quite easy to make apps without any previous programming knowledge. Say that making the application is done through this way, but still you will need to set up a base code in your board, in your Arduino, ESP, or Trinket, or whatever board that you have with wireless connection. Sorry, I was going to go Scratch 15 years ago. Okay. So if you log in into MIT App Inventor, actually let's go through the web page, MIT App Inventor. You can see a lot of examples of different apps. Has a lot of things, so you can just create an app, you log in, and you will reach this area that is your base folder, because everything is saved online. You don't need to save in your computer. Everything is saved in your account. Works more or less as Fusion 360 in that way. So what you can do is create a new app. For example, I have created a few apps, so you see some of them are quite old, but they still work quite well. So let's make this one, test app. Before jumping, I'm going to go inside one. What we have now, as you see, is a little emulator of what the phone is going to, current session. Make this session, because I have two browsers. Make this the current session. So I go inside. So as you see, we have a basic phone. It's not an emulator by itself, but it's more like visual. That is going to be the representation of your visual interface. And I will say that the worst point of MIT App Inventor is the aesthetics doesn't look exactly as they might see in the final result. So, for example, if we put a button, why is it going so slow? I think it's a zoom. Oh my God, really? It's just drag and drop, and you can have already a button in the moment you open your screen. This button in here, we just configure the aesthetics. For example, the font size, for example, 30, the size, the height and the width automatic. This is gonna automatically adapt to your phone size. And actually, this is something that when you develop an app, you should need to be really careful about, because almost every phone has different screen sizes. And if you set up, for example, a button that works in pixels, let's say 50 pixels, this in a small phone will maybe get out of the screen, and it's something that you don't want. But let's go into this later. And you have the blocks. That is what is happening behind what is the raw code of your app. So for example, we have some, let's say, statements of like Arduino, like if, we, remap, etc. And we have the activators, or let's say your pieces of visual code translated in the raw code. That we have the links for the when button. When I click a button, this something will happen. And what will happen? Everything that I have here. I'm going to show you what app we're going to build today.
Sorry, Edu, how do you, no, I think I saw it. How do you open the blocks with the right upper?
I will go through it again, don't worry.
Okay, thank you.
So for example, I have written this little app that is a simple LED controller through Wi-Fi. And as you see, I have set up a title, like 3 buttons. We can see here, button 1, button 2, button 3, and these weird things. Actually, this is like enable a connection to the web because we're going to use Wi-Fi connection, and that basically is web, and activity started. That is a trigger. The blocks will look like this. Actually, making an app could be as simple as these 3 blocks. I'm going to show you what exactly this does. This is my Arduino. I already upload an Arduino code through it, and I have my phone. Both I have set up that they connect to the same network. That in this case is my house network, the 2.4 gigahertz network. And I have already an app that is this one. I even put an icon to it. So I'm going to click on it, click, and I have my phone automatically deployed. So when I click on, this is difficult to do, tick, my LED blinks. And I can switch on and off my LED. And this is just a basic digital output. You can do this in analog, you can do this with PWM. I could not be done, I think, with App Inventor, but you can do like analog writes that you can actually emulate PWMs. And I also enable a third button that, because the good point of MIT App Inventor is uses all the sensors, for example, the gyroscope, the camera of your phone, and by so we can enable to do multiple things. For example, you can move a servo based on the tilt of your phone. Actually, so you don't need to build a button interface. You can use the gyro sensors of your phone or the shake sensor of your phone. So it's quite powerful in that way, because this is a small computer by so, and small computer with lots of input sensors and output sensors, for example, sound. Actually, you see, I have made it a little bit responsive, so it self-adapts when I rotate. And I also enable another button that is the Let's Party, that automatically opens up a YouTube player on the phone app. For example, I have here another app that I want to show you that is a quite, more complex app with this Sphera. So for example, how to make the interface, the UI, looks completely on you. And the aesthetics is something that you need to be really careful when you want to create phone apps if you don't want to make them look really, really, really ugly. So in a way, the designer point of view of MIT App Inventor is like an illustrator that works with layouts. You can have vertical arrangement, horizontal. It's kind of Illustrator mixed with HTML, CSS. So for example, here I have some logos in that case, and I have a connect to Bluetooth, and I have another one. So in this case, I'm going through different screens. So I have like multiple layers as a Photoshop layer, as a presentation of a Illustrator layout. So you can not only work with one screen, but you can do with multiple screens and jump between them. So you can make the apps as complex as you want. So for that, actually, I always prefer I don't like too much the change that Neil has done of explaining interfaces before networking, because in this case it makes a little more complicated. But let's ignore the first part on actually how to connect Wi-Fi. In the class, here I have already uploaded the full code of Arduino, APK of Android. So actually, if you click here, it will automatically download, if you save it, the installer for your Android. So actually, you can install, if you want right now, your Android app, and it will work. And here I have a what is called the MAT exporter. Let's say the MAT saved file, saved project, so you can open in your MAT session, MAT App Inventor session, and start from that one. Let's say it's this base code, so you will be able to edit this setup of blocks and buttons. Why? Because the APK package that basically, I'm going to open the repo so you can actually see what is the folder, desktop, Fab Academy. This is the class repo actually. I'm sorry, is docs, material, extras, week 12, assets. So the what is APK? This one, if you set up and download it in your Android, this is a self-installed package. So when you click on it, it will open up and say, do you want to install this app? Yes. Do you want to, like, and it will warn you. This app doesn't come from the Play Store. Do you really want to do it? Is it safe? Do you know the source of it? I promise I didn't enable location or anything like this to track you. So with this, you can already have a base code to work with. What you will need, a Node MCU or a Wi-Fi dongle for your Arduino, a laptop, of course, a digital output. You can use an LED or an analog, and some jumpers in case you don't need it. So let's see what's happening in the Arduino part. In the Arduino part, this is the Arduino part. The first thing we need to set up is configure the ESP to work with Wi-Fi. So for that, you need to include some libraries like the Wi-Fi, Wi-Fi client, Wi-Fi server, etc. And we want to work with the ESP as a web server. In short way, web server means that you are calling addresses, web addresses, the same as this one, inside your Arduino. Let me go to the Arduino. For that, you need to connect through a network. We are going to do station mode. That means use, for example, a already built network. So the ESP doesn't need to deploy one. So you will not connect directly to your ESP. What you will do is use your house network to connect through it. It's going to be a bridge. You need to set up, of course, your SSID. That is your Wi-Fi network. I suppose most of you is 2.4 something HALA house network, or I don't know. Your password, and you will deploy a server. We will use a serial connection, the standard that you have already used, for debugging. It means so we can see in the serial monitor what is really happening behind. Because sometimes debugging apps through Wi-Fi is kind of difficult. I'm going to set up an output that is going to be the Arduino LED. And this little piece of code is going to actually show me what the web server on the Arduino is doing automatically. So it's going to automatically connect to the network I'm giving with this password, and it's going to, if it gets the connection, it's going to stay connected, and if it gets started, it just started. If not, it will say network could not be accessible. I actually don't know what is saying that, but it says like invalid access, or I cannot connect your network because maybe you wrote your password wrong, etc. What we basically want to do through the void loop is wait to a quest, or wait for our request. What is our request? In the moment, for example, you state you are typing google.com, basically you are asking a server to give you the web page, no? We ask Google and it's answering us with this. So we're gonna use the same kind of protocols, but this is called a domain. Usually behind this domain, actually the real address looks something like this. It's a number. So what we're gonna do is state addresses to our Arduino, and the Arduino is gonna respond with answers, or it's gonna do things. Because basically we are sending to the Arduino, hey, I'm contacting you, so you do something and you send me back something. Sometimes you don't send back things. In this case, we are only sending him instructions through sending IP addresses. So the Arduino is gonna be basically waiting for IP requests. When there is an IP request, it's gonna say, okay, first I need to send some code that is the answer back to the interface, could be the phone app or the web app, saying that, hey, I received the message. And what we're gonna send really matters, because in this case, actually the address, I have the Arduino already connected, and I'm gonna open the serial monitor. Where is the serial monitor? Oh, here.
Edu, in the Wi-Fi at the top, the very first line where you say Wi-Fi client, sorry, of the loop, when you say Wi-Fi client, if not client, return. Does return mean don't do anything after the loop, just start the loop again?
No, exit the if conditional, so you are restart again and run again. Like it's kind of try to redo the loop all the time for clients.
Well, actually, that return will probably close the loop, so all the rest of the code that's inside the loop will not run.
Yeah. That's what I was wondering.
So if I reset my Arduino, for example, it's connecting automatically, and it's gonna send me what is the real address in my network of my Arduino. So I can copy, and of course, if I paste into my browser, it's not doing anything because I haven't programmed to do anything right now. But in the Arduino code, I have a state that if I send the address and GPO 0, GPO is actually the condition that I have sent here to my pin. GPO 0 will be translated to pin on, pin off. So if I paste this and I just state it after my address, I will turn on and off my device. What happened right now is my computer is not going to work because I'm connected to another network. I'm connected through 5G, not 2.4G, to have this class. So if I do it in my computer, it's not going to work. But basically, with the phone app, what we are doing is using on the back of the phone, we are running everything in high. We are basically sending this address request to the Arduino. So when we send this address request that is 1.192.168.1.135 GPO 0, we are sending basically LED on. When we send GPO 1, we are sending LED off. So basically we are calling, let's say if you want to make a equivalence, we are ringing the door of the Arduino, and the Arduino we have programmed to have like 3 different buttons to ring on, and we do this through Wi-Fi.
Edu, sorry, in case we don't have a library, where could we get it? Because I was trying it with and it says web server, no such file or directory.
Yeah, you just need to install the Wi-Fi libraries for the it's the standard Wi-Fi libraries for the ESP Just call for Wi-Fi, Wi-Fi client, Wi-Fi secure. It will install as our already package. How to install libraries? Include library. Sorry, you go to the top. Super slow. And you click manage libraries. This will pop up the library manager, and you can just look for the libraries here. Okay.
I have a question.
So I just look there for the web server.h or the library I'm missing.
Just put ESP Wi-Fi and it will automatically, these libraries are don't load as a package. Usually you don't load like 4 or 5 libraries at the same time.
Thank you.
Let me look for the ones I have installed. Installed, for example, Wi-Fi. I have Wi-Fi, ESP framework, and Wi-Fi manager. I think it's Wi-Fi manager, the one that we are looking for right now. So your set of instructions are going to be based on a request. So if the request of the IP, this IP address is GPO0, I'm going to assign, I have a variable, I'm going to say that this variable is 0. And I'm going to say the condition in the outer loop that if my digital write is going to depend the value like on and off, high or low. High is 1, low is 0 in this variable, and this variable is going to be defined by the IP address that I'm calling for, that I'm requesting for. After doing this, the ESP is going to close the connection and look again for a new connection. And it's important that we do this quite fast, so actually we don't have delays. If you put a delay here, for example, of 5 seconds, if you send the request, meanwhile it's waiting in the delay, it's not going to respond. It's going to miss the request. So you cannot have delays in this loop. So if you want to use, for example, move and stepper that you actually need to use delays, what you need to do is use interrupts for it. So everything you need to that uses delay needs to be transformed into interrupts. For example, blinking an LED in that way.
If you don't want delay, why do you have a delay of 1 second?
It's 1 millisecond. Okay, it's 1 millisecond.
I mean, yeah, 1 millisecond, but why not just not have the delay?
This is about refreshing speed of the cycles of the Arduino. So if you don't put the delay, it overrides the memory, as far as I know. Like it buffers the memory and jumps at some point. So in some cases, you want to have a really small delay. Like usually it's 5 or 1 millisecond. Okay. And actually, I have another one here that is I'm waiting for the client. So let's go on to the everything already explained here. So let's create an app. So basically you go a project, start a new project. Based on the design, I'm going to recommend you to look at the material design IO. That is basically you put material Android UI. Have you noticed that lately most of the apps looks aesthetically really similar? Like they have the same structure, and it's the same as the phone apps like 5 years ago or 10 years ago, that everybody was crazy and each app was completely different. Now they all have the app on top, and this is actually to make the interface as easable to interface as possible. So actually, this is about rules or recommendations on how actually your app should look like. And they give you, like, for example, navigation, understanding navigation, how a traditional app navigation works like. So this gives you a lot of clues on how to actually make a proper navigation interface. For example, with the color, it's really important to have an app that looks nice, the color. And this gives you, for example, limiting colors, color usage. Actually, what is the color? Color system. I think it's here. like harmony between colors. A button that is white, yellow, and a really thin typo that is white is not going to be written properly. So if you have a yellow button, like this case, you always need to put the letters in bold. And you cannot use serif. You need to use sans serif typographies because serif is not read properly on white and yellow. So this kind of clues and rules of design iOS has also these kind of libraries, but the Android one is quite well documented in an easy and really understandable way, at least from my point of view. They also state, for example, dark themes that are really common right now to save battery on your phone. How you translate what you think was a colorful app into a dark theme app. How to preserve energy. This is just some design tools that I'm giving you. So let's make a new app from scratch. Projects, test app. So I have the main screen. That is the definition. So let's say I want to put just 2 buttons in the center. If you want to put 2 buttons in the center, you can just use the main screen definitions. For example, I want to align everything to the center. I want to align, as you see, I'm not clicking the button. I'm setting up the arrangement of the main screen. I want to align everything to the center too. I want that the app name, the name that is gonna show on my main phone screen is gonna be test app. What is the background color? For example, of course, if I'm using a dark interface, I will use it black. In my case, I don't care too much about battery saving, so I'm gonna put it white so you can also see better. And you're gonna use a background image. Actually, you can put a background image that covers the full background of your app. But with so, you need to think that your app, always that you put lot of images, will behave slightly slower. Saying that it was a common problem like 3-4 years ago when the phones were not that powerful. Nowadays, you really don't care. Just you will make the AppInventor package larger because you will have images inside. It's the same as an HTML. You will want to make everything as light as possible. Block toolkits. Actually, this is to match other experimental things. Close screen animation. You want to fade in, zoom, like different animations between the different screens. Icon. Do you want to upload actually an icon for your app? In this case, I just took a small PNG and uploaded a FabLab logo. Primary color. This will define the primary color of if you have a top menu bar, and in this case is this one. So I'm going to choose yellow, and primary color dark, I'm going to choose light gray. Screen orientation is going to take care of the orientation sensor of your phone or not, or be forced to actually be in landscape. You have seen that if you have playing a game in your phone, always switch up to horizontal most of the time. So it's forcing disorientation. You can force only to be used in vertical, for example, as Instagram. When you use sensor, do you want to scroll? It means your screen is going to be bigger actually than the phone size. In my case, and actually I found out that making apps scrollable with MIT App Inventor is quite tricky. I never put scrollable. I prefer to have several screens, but that you can always see whatever is in the app, the same as your phone size. A status show bar. It means you want to see the main buttons like batteries and things of your phone. And sizing, responsive. You always want to have responsive, especially for the phone, mobile phones. And actually here you can see that the font size, in this case, this font size is super small. This UA was designed like a lot of years ago. So I always put tablet size. And actually a tablet size is nowadays a 5-inch phone that is more than common. You can also use this as a monitor size that will be more like an iPad size right now. Can you set a custom size? No. But this is just for a pre-visualization, Benji. It's not for the real output out interface. We're gonna say the title. Title of the screen is actually gonna be the main title on your phone. So in this screen, so for example, it could be main screen or control zone or like whatever. In this case is control zone. You want to see the title or not? You can hide it in case you don't want to see it. And you can put the version code in case you are coding and debugging all the time your app, so you don't misunderstand which is app have you actually installed your phone. Because the best way to code for a phone is actually download all the time the apps and test them. So as you see, Android has always the 3 points that is by default. And it will show you about stop this application and about this application. And it will show you the version control of your app. Let's go to the button. The button, you have statics configuration, background color of the button. I'm going to put a yellow, super ugly yellow. So actually make a custom one. It's not going to be the best one, but and I'm going to copy this one for the future. Done. And I'm going to use a font pot because I'm going to use a yellow and white. I want to use a font size. This is something that you need to go on experience. I will say that font size below 15 on a phone, on a normal phone, doesn't work really well. I will always work above 20 or 25 pixels on the font size of any on any device. Font typeface. You don't have too many options. I will use sans serif, and the height of the button is automatic. Like it will adapt to the standards of the MAT App Inventor. So actually, you don't have control of it. You can say fill parent. Fill parent is when you work with horizontal arrangements, for example. With horizontal arrangements, you can set up like partitions. Let's say a grid layout like InDesign. So in horizontal arrangements, you can set up like zones. For example, I want that this one is always aligned to the center. The problem with horizontal arrangements is you actually don't see them. It's something really annoying. Is you see them like this, but these are not gonna be shown on your app. They are like virtual grids where you can put things inside or outside, and you can have different arrangements one after each other. So actually this will align. Let's go with it. I'm gonna put it fully width, full fill parent. It means go completely on the screen size. Actually, this is the most difficult part of the interface this thing. So actually, for example, I have this one is a horizontal arrangement. So if I throw another button, it will go side by side. A vertical arrangement will be the opposite. And basically, you don't have too many options. So you have these layouts. So you use the scroll if you want to scroll horizontally. If you want to scroll horizontally, I recommend you to go to force mode to horizontal mode of your phone. So you slide left and right. Let's say like a gallery of phones. In this case, I don't want to use horizontal arrangements because I just don't need them. So I'm gonna erase them. Okay, I'm gonna go to text button, font size 30. I know this works well. And I put that the height is a percentage. So this will automatically scale the size of your button depending on your screen size. And actually this is what gives the most permanent aesthetic looks through all the devices. It doesn't matter if it's a tablet, if it's a super big tablet, it's a really small phone. So this height, for this, I'm going to use, I think, 50%. Okay, and the width, this is actually the Android aesthetic looks. I'm going to use 95%. That is almost until the border gaps, because these buttons usually never reach the ends.
What's the green line on the right?
The green line actually is because I have the button selected.
No, on the right of the screen. on the right of the button? Like if there's a padding or something?
No, it's a bug of the program. This is not a bug. It's no. Sorry, I never use it. It's the scroll, but it's the scroll zone. So if you scroll up and down, but this only happens when you use the horizontal scroll arrangement and you fill it completely. The problem with the scroll arrangement and why I don't especially like it is to actually see the scroll happening, you need to fill completely with percentages all your phone. So when it's full, it will automatically deploy the scrolling. If you don't, it will not deploy it. Like, let's say you cannot scroll over an empty screen. You can put the text of the button on off and text alignment and text color. I'm going to put white. And I'm going to say that this button is visible. Why? Because maybe you want to have an interface that when you press on, the button disappears and changes to a button that is off. So actually you only see one button at a time. So you can hide and show buttons at different and with different activations. So for example, if I have this button that is actually off button, 30 background color custom.
Can't you just copy the other button?
You can, I don't know, no. Font bold, width 95%, height 50%. So for example, I can state that this button is, is off by default, and it will only show up if I click on. And when I click on, the on will actually disappear and will show only off. So you can set up this kind of rules. I'm going to make a super simple interface, so to make it keep it simple, so I'm going to just keep these two buttons. And what I have to do now, right now, my app is not enabling anything. So I want to use Wi-Fi. For that, we will go on through connectivity. What we want to do, use Bluetooth as client, Bluetooth as server, serial, because actually with Android, most of the phones, you can connect an Arduino directly to your USB port. That is actually something really powerful. And web. Actually, we want to deploy web actions because we want to use the IP and Wi-Fi connection. So we just throw it. And as you see, it's not anymore. It's just in non-visible components because it doesn't have a physical layout, well, physical digital layout, but it's showing as an option. And we can set up automatically URLs, like go to an URL or not. In this case, we don't want it. Once we have set up this, we have already everything physically. Actually, I don't like the control zone, so I'm going to disable the show status bar, title visible. I don't want it. So it's clean, super simple and minimalistic app. I'm going to go to blocks. That is what is going to actually deploy everything. So here I have multiple conditions, like if, then, else. Save the empty screen now. Okay. Do you want to have different conditions, values, open another screen if you have several screens? Actually, didn't show you where were the screens. The screens are here because it's not obvious, it's not in this zone. So you can have another screen. This sometimes a little bit slow. Okay, so now I need to start since the beginning. As Benjamin was stating, we cannot copy things and properties from one screen to another one. It's quite annoying, but it's how this app works. Let's go to blocks, and we have the conditions. And actually, in the blocks, each screen has a block screen associated. That means screen 1, for example, a button. I'm going to state the conditions for a button. If I click a button, if I jump into screen 2, it will be, I have to set up another blocks of conditions. So when you move from one screen to another one, you need to set up exactly the same rules if you want to use the same component or set up your new design rules. So it's something that you need to be careful about. So when I click my button, you have different ways of interacting. It's not the same as double clicking, long press, just a click, or when you touch and you keep press, and what happens when you lift up your finger. So actually that's what we call touch up, touch down, lost focus. This is mostly if you are dragging your finger, but you are not pressing exactly on the button. So lost focus is when your finger is on the top of the button, but you didn't press on the top or not. Those ones are a little tricky to use. Or long click or hot focus. The standard one is just the click. So when we have a click, what we want to do? We want to go to web. That is, we want to call a URL. Let me see what is the set web URL, because we want that the app calls a URL address. So what we need to do now, set up the URL. So we go to text and we put fill. We need to text which address we need to call. How we know the address we need to call? This is something that you do it in your Arduino, because this will change. For example, doing this in Ajax is really annoying. Why? Because we have, for example, the Fabla Barcelona router, and we have a lot of devices connecting all the time, connecting and disconnecting. And by so, the addresses are changing all the time. So each time you want to do this, you need to look actually for your IP address. How to look for the IP address? If you go to the serial monitor, when I'm going to reset my Arduino, it's connecting, and it's going to show me the address. So this is my IP address right now for my Arduino. This, you can actually force to always have a fixed IP address and a static IP address. Some people are talking to the chat. I got the static addresses. Yes. So you can call static addresses, but that's something that you need to know slightly more. And this part, I think Oscar will cover into networking. Let's go in the simple way right now. So we need to call this address, but it's not only this address. This is the main Arduino address. What is the address to send a set of instructions right now? Is this GPO 0. So actually, with the button, when we press the button, what we're going to send is to this address, we're going to request for this. Let's state also the button 2. In this case, I can just copy. It's the only part where you can copy the blocks. So button 2 is the same, but we're going to call GPO 1. Okay, we have go to set this, but we need to get, right now we have set the address. How to explain this? We are configuring the app to actually go onto the address, let's say in a virtual browser just behind. But we didn't click the enter button. No, we need to confirm that set of instructions. So it's procedures, I think it's in web 2, is cal web1 get. Let me confirm that is exactly this, because as you might think, I don't do this every day. Yes, so it's web1 get. That is set. Oh, sorry. Set web1, because we can set to call different webs if you use different web components. So we can open different calls to different IPs. Let's say you have a network you have 3 Arduinos connected in your house, and each one has a different LED. They are all connected to the same router, and each one will have different IPs. So actually you can set up different web components to call each one of them individually. So we just copy the same component, and actually the app is ready to be exported. This is an ultra simple app. Let's see that everything is okay. Okay, so how to actually we compile these apps? There are different ways to connect to your phone. If you don't have an Arduino, an Android phone, you can use an emulator. So this will open up an interface. I don't have you need to install a package for this. Emulator, maybe App Inventor. It's quite ugly. It's one of the ugliest things that you can see. That will open up a super fancy Android phone on your screen. Like looks more like the first Android phones, but it's a phone. So you can emulate the phone. You can use USB connection to your phone because you can have you use your phone charger USB cable cord to your computer and have automatically the app downloaded through USB, or use the Android code through the USB connection. Or you can set a companion that I actually don't know what it is. This is something I never tried. It's new, or at least from the last time I used it. You can build. That is something that you usually do. Is, for example, you can download the APK to your computer, so it's compiling the app. Usually, yes?
I think the AI companion is probably an app you can install on your phone to send it to like some emulator on your phone.
Good to know. What compiles? Companion. Okay.
I put in the chat, I found the Google Play app.
Yeah. Okay. Well, I will look it for it later. So right now I have the APK. So this, if you have an emulator on your computer, you should be able to use it. In this case, I have an Android app, so I will save this to my phone. Another way that I found really useful is a QR code. So this will compile the app and it will give a QR code. Actually, I'm going to show on my screen. I don't know if you can see my other screen. I have a QR code scanner on my phone. I am going to scan my barcode. So I scan the code and I'm just going to go to the address and it will automatically download the APK package into my phone. It's just another way, so you need to save the file into your computer and after paste it to Drive or whatever into your phone. So right now I'm just, has downloaded the file. I'm going to open it. As you see, it's the install menu. I want to install. So yes, install. Whoop. It's installing. And it's saying block data protected because it's not a Play Store app. I say install anyway. It's installing. So now, wait, I don't want to send the app for scanning. So right now I'm going to say open it. And I have the app in my phone. So theoretically, it should work the same as the other one. Let's see if I did it. Okay. No, it's not working. Always this kind of thing happens. Let's see. I'm connected to the same network. So live debugging. Real life debugging. So let's see what is happening. So the blocks, when button click, set GPO 0, GPO 1, web URL. Actually, should be like that. Okay. Something really silly, but I'm setting actually an IP address. I'm missing the HTTP. part of the address. So I'm just going to type it, http // no, I think it's like this. Yes. And let's see if I don't forget anything. Actually, the buttons are reversed right now. So I'm going to put 1 to switch it on and 0 to switch it off. And I'm going to build it again.
You forgot the slash.
The
slash.
Okay. Too late. I already clicked compile. You cannot cancel it.
You can just switch it on now. You can't switch it off.
I'm going to scan again. The moment it shows up. Yeah. The keyword that gives you only lasts usually for 2 hours. Usually I find out that it lasts a little bit more, sometimes less, but it's around 2 hours. You are safe to use it. Download. I'm downloading again. Open, install anyway. Open it, and yeah, it works, but I cannot switch it off because the code is wrong. Say that this is one of the simplest apps that you can do. So I'm going to show you a slightly more complex example. For example, I'm going to show you the Spira app. Actually, I'm going to show you, for example, how to call a web. That is the less party button. In the less party button, I have state something different. For example, it's connectivity, activity started. Or let's go a little bit through the different things that you can set up in the interface. Because we have a little bit of time. You can set up a checkbox. A checkbox will work exactly as a button. When the checkbox is on, it will be 1. When the checkbox is off, it will be 0. Date picker. These ones are slightly more difficult to use because the components that are behind. You can set up images, level, list picker. For example, you can scroll through analog values from 0 to 255, for example, or to make fades. That you can do it the same with a slider. Unluckily, the sliders are super ugly in this app. Okay, sorry. Let's delete the slider. You can spinner or switch. Switches are nice. Text box and layouts. Seems like for those, so the app, the app somewhere. Yes, the app is stored into your account. It's online. So right now, if I close my browser, the app will be saved. I don't need to save it. You can set up media, like open your camera, for example, player, sound, recorder, etc. For example, you can set up a sound recorder that sends you automatically the sound through to a Dropbox, or actually outputs to your ESP if you have a MP3 shield, something. You can make animations, simple animations, maps if you want to embed Google Maps, sensors. You can use all the sensors of your phone. For example, not all the phones have thermometers or hygrometers. So I don't know which kind of phones are those ones, but social, you can actually use the agenda of your phone. So actually you can set up a button that is, if I click hide, also call my mom. Or storage, if you want to use online storage devices, and connectivity. In this case, you have the activity started. Activity started is just a piece of code, the same as web. That what it's going to do is a trigger to use other apps of your phone. So, for example, if I want that each time I click this button, it goes to a web address, but this web address, for example, is YouTube. I want to actually open the YouTube app. No, that's usually what's common. Or use the Flash or HTML viewer of YouTube. So actually need to put the active started just as a class. So if we go to blocks, I have basically what I want to start. I don't just want to call to the web URL. What is different between web and activity start? Because actually I'm calling just an address. Yes, but in this case, I'm calling an address, but I don't want to see what is happening. I don't want that my app actually opens the browser and calls this address because I don't want to get out of my app. In this case, yes, I want to do it. I just want to actually open, like call this address. I want, this is something, some sneak codes that is an Android convention. You will need to look for, usually when you want to open a view, another app is this. Android intent action view. That means I want to see actually what is happening, not do everything in the background. And I want to start my activity. So I want to, basically, the code is activated like this, but really it's being activated in this direction. So I want to start the activity. So I want to go and view this address, but you need to state it in the opposite direction.
And what's URI, data URI?
Is how to set up the addresses. Actually, I don't know exactly how to use these ones. This app can get really, really, really complex easily. You can make really big snitches of code. So I'm going to show you, for example, another project that is more complicated. Is the Spira. This one was not the final. Actually, this is the final. But it takes a little bit time to. As you see, the app here is not published. It means it's private just for me. If you want, you can also publish your apps inside the MAT App Inventor store. It's not a store because you don't buy the apps, but you can allow the code to be published to other people. Oh my God, it's super slow. I'm gonna refresh. Okay.
Can I ask you a question?
Yes.
Is it possible to, for example, have a key on a Arduino and like click it and something happen in the app?
Yes, you can do it in both directions, direction.
Okay.
Actually, this is how I was doing with the app that I'm trying to open that works a little bit slow. I have that control. It was showing me, I think, this was for controlling a photobioreactor that is basically a water light control for cultivating algae. And I have some sensors. So actually I was getting the sensor reading from the device to my phone. And based on that, I could manually activate different things. So in this case, for example, it's a simple app. And actually this app, you see, Benji, that is great. That is something you call about, it's really like that? No, actually it's not like that. What is the app? The app aesthetically looks like this. And this is something that I really don't like about MAT App Inventor, is the aesthetically looks like you need to keep a like overview of what you really set up on the background, because the color in this case is this one was not indexed properly in here. And why? Because I have set up first an image that is not indexed properly because it's transparent. The background in this case is gray, but actually it's not. Maybe it's not this version, but the other it was the maybe the 3. Well, in this case, it doesn't index properly for sure, and sometimes it doesn't show up. For example, here I have a logo. This image is here in theory, but it's not getting preview properly because the screen size of the visualization is not good. So sometimes you need to work a little bit on the back or change the tablet screen. So for example, you can see in this font size, it's not shown properly, but in the tablet size, yes. And you need to be changing between the different kind of interfaces. And it's not gonna look exactly as it might look in the final version. So it's really important to be testing all the time, back and forth, your app, especially on the aesthetic point of view. So in this case, I have different screens, one to have a kind of PDF guide, one to connect to Wi-Fi, in this case it's Bluetooth. So when you connect to a device, it will automatically switch on the Bluetooth, and second, show you the list of Bluetooth devices. And you select one, and it will automatically go to the main screen that I think is screen 1. And share the experience, this button, actually what it does is opens up your camera, you take the picture, you click confirm, and it will automatically ask you, you want to share it to Instagram, Facebook, whatever, with a message already predetermined. For example, this app is awesome. You can predetermine like complex actions. Let's take a look a little bit of the block code on this case. So you see, this is mostly aesthetics, half of it, but we have the first part, that is, when Bluetooth devices, it means if the Bluetooth of your device is on, list all the addresses and set the one that you have selected. If the Bluetooth is available, then show me all the addresses. It means show me all the Bluetooth devices connected. This is before picking. It's show me before I actually click the button. If I pick something, if it's available, connect to it and vibrate, for example, so have a feedback on the interface. If that happens, for example, if I really click and it's enabled, vibrate again and jump to another screen. If not, vibrate longer so I can have the interface like the feedback that is wrongly connected. In this case, if I click another button, because this button is not the same, it's go to another screen and vibrate. Share, and in this case is, what is the picture? Sorry. Yeah, if I click share, call camera to take a picture, vibrate for it, and after the picture, share my image, the one I got, the image that I just got, with a message. And that is opening like your Instagram or something. And in this case, it's initialized. Okay, now I remember why it's like this. Because the color here is some before. Yes, exactly. The background color before 2 years ago didn't have the custom button. You only can choose these colors. So what I did is enable this in a code. So when the screen inlays, I set up the color, this one, exactly the RGB color that I want. So if you set up in the block, it doesn't index properly in the main screen. Because you can set, actually don't make the configuration here, and if you want, you can do everything by blocks, if you feel more confident. I want to have like something in between. So, and also to set up some messages, like warning messages. If the Bluetooth is off, please switch on the Bluetooth or these kind of things. So let's go, for example, to activation, that is bubbles, I think. No, this is screen 1. Is it screen 1 or is it screen? As you see, taking up the names properly is quite important. So in this case, is different activations for each button. So this is a basic. Oh my God, this is.
Is there any order to what's being run there, or it's kind of like all just random?
No, you mean if it's kind of a loop, the same as a no, it's not a loop.
Okay. Yeah.
Because
it's
you have
when.
Exactly, because this is a microprocessor, not a microcontroller, so it doesn't run a set of instructions in a line. So the behavior is different. So you can just set up a set of instructions that only gets activated wherever they are activated. So for example, when I click the button bubbles, set a variable as any Arduino variable, and I'm going to set global B to 1. And after setting up that variable, I'm going to call the Bluetooth actions. That is, if I want to send a variable through Bluetooth, that is going to be text B. Why? Because in my Arduino, to simplify everything, I just state a abecedary. Like if I send A, is activate motor for 25 seconds or something. You can also state to actually activate it straightforward from the code blocks. But for me, from my point of view, I think it's just easier to send just a small command that activates something in the background of the Arduino. And like vibrate, and after you get active, send that message, also change the button color code. So actually you have a visual feedback, not only vibrations. And basically what you do is assemble a lot of these small codes. And you see here, I have setting up a variable. And you always have to assign any code, you need to initialize that variable. Basically, that's how you build a Inventor app. In the page, I have stated instructions on how to do exactly everything. Well, basically, you can review this session that we always record, or you can follow the tutorial that I did online. And this is to actually have the options for most of the MDF that doesn't have the Wi-Fi, how to actually use a Bluetooth connection. That is slightly more complex, but not something that you can not afford. And actually the part on the Arduino is lighter because you are basically the Bluetooth connections for Arduino, they just connect through serial. You can just connect straightforward through serial, or you can emulate a software serial. You have, if you want to go slightly deeper, what you can do, for example, is set up Firebases. That is writing from your phone to a file, for example, a JSON or CSV that the Arduino is connecting and calling through. So actually, you don't connect directly to your phone, to your board, but you can control it over the internet. That is usually what you do. For example, if Arman has a Arduino and I want to control through my phone app, I want to use, for example, a Firebase to actually write the instructions to the Firebase and the Arduino read instructions from there. So I don't have direct access because it's something that you cannot do it because of router and modem security features that they are not enabled, like straight connections between points. And another one that is super silly, but I found it funny, this tutorial, that is actually how you make a park assist, the ones that for the phone that beeps, with ultrasonic sensor connected to your car bumper. Super nice integration. Eh?
Neil will be happy.
Exactly. How to basically make an app to warn you visually with the phone so you don't crash your car. And say that, well, the class of the MIT App Inventor is over. And tomorrow we have A-Frame that the ones of you that love software will love it for sure if you haven't tried before. And later on, I will do web app that is basically web server that this is going slightly, oh my God, sorry to hover that fast over everything. Web server, actually how to publish web pages from your Wi-Fi, your ESP, if it doesn't matter if it's ESP8266 or ESP32, 32 has just memory. So instead of having to control through an app, how to actually access a web page. So what we're going to do is make web apps. So the web page is going to be stored in your Arduino, and we're going to call is through the browser interact with your Arduino. That is nice in a way that you don't need to install anything in your phone. So it makes it more usable and in a more straightforward way. That has a lot of constraints, usually about memory size, what kind of things you can do, and the speed of connection, but it's good. At least I like it personally. And we will show some applied projects that we have done in the lab on actually making web app interfaces with PCB control. That's it. I hope you liked this class. Do you have any questions about today?
Yeah, I have a problem. I'm still looking for webserver.h. I have installed like, I don't know, 30 different libraries, ESP8266 libraries, and I can't find it.
Really? Okay, let's open. Okay, maybe I know.
Maybe Pablo can share his screen instead.
No, I know what's the problem. Is you don't have the JSON of where to look for the library set up in the preferences. So I'm I'm going to copy if the Arduino opens. Oh my God, Zoom takes so many resources of the computer. So if the libraries doesn't show up in the library manager, it's because you can set up in the preferences of Arduino additional board managers. It not means libraries that are not meant by default. So I'm going to just copy all the ones that I have. Quite standard, let's say for a Arduino Fab Academy course. Where is the chat? Just paste them straightforward.
I have to paste them one by one or all of them?
In line like this, just jump a line between the different addresses.
Okay, thank you very much. I'm going to try that.
Actually, in this case, for example, we have the editing support, the ESP. This one I think is quite old. This one is, I know, it's the same as this one actually. I have duplicated, but really doesn't matter. The expressive, that is some special libraries from the Wi-Fi, Adafruit libraries that are always nice. Neither remember this one, neither remember this one. More expressive libraries. And mini core, that is a super nice 8010 core, but better developed. That enables USB in a raw connection to 8010s with different clock speeds. So now that you go to libraries, manage libraries, la la la. Let's go to Wi-Fi, install. Just take a screenshot of this.
Wait. Done, thank you.
Okay.
Edu, can you explain one more time the requirements for this week?
Okay. Requirements for this week. I think we already updated for. You mean requirements for MDS or for Fab Academy?
Fab Academy.
Okay. Let's go over the assessment. So yes, you need to use a electronic board that you, in theory, you should have produced this board, but right now because of confinement, you cannot produce the board. So if you don't produce the board, it's not a big deal. You have to either use inputs or outputs. You can also use both inputs and outputs and produce an interface for it. By so, that means, for example, an app to control the output of your Arduino is an interface. If you make a web app, or actually the Arduino sends through the USB connection the data to processing, and in processing you see a graph, that's an user interface. Before Benjamin state exactly describe component.
Interface is a user.
Yeah, interfaces and user, graphic user interface. So a plot of a graph is an interface in the way, yeah, we see the graph, but you don't interface with it. It means you cannot do anything with it. So if you are plotting just a graph, for example, state a button that the graph color changes. Let's something that you can interact with it. If in case of outputs, it's already by default a user interface. But graphic user interface means basically something that is publishing data in a graphically way. For example, Arduino, let's say Grasshopper. Grasshopper is data, but Grasshopper is a visual interface scripting. So it's a GUI, graphic user interface of scripting, because actually we do with blocks. We don't do with lines of code. So for example, kind of a Easter bunny of this will be to actually make an app that just moves the line rows of code through the screen. And if you click on one line, actually activates something. Because it's a graphic interface, but with code still. Really bad joke, but so usually a lot of people, to take an example, they use just the 80Tiny44 with the hello world, and they have a button embedded onto the board. So actually they do kind of a Mario that is moving on processing with some little like motions. And when you touch the button, the Mario jumps. That is a super simple interface, but the point is to get to know how to make something that is visually attractive, that is interacting with the physical world, not just a computer. And actually the assignment for MDF is exactly the same because it's the bare minimum that you can do. More questions?
Nope. I mean, I have usual conflict of the hours, but could be after the recording.
Okay. So apart from personal questions of Magdalena, we have more? No? Okay. So I'm gonna stop the recording. The class is over.
Gracias, Edu.